Hi, I'm Jake Bertram, and today I'm going to talk about climate change and inflation. Specifically, I'll be approaching the question, in what ways do climate change and inflation intersect? I'll start off by talking about climate disruptions and capitalism and delving into the Marxist roots, specifically talking about the concept of metabolic rift. I'll then look at some studies that measured the impacts of climatic events on inflationary forces. I'll first look at the longer term by looking at global and regional temperature warming, looking at some historical impacts and then future projections based on those on inflation. And then I'll look at the shorter term, so 0 to 5 years rather than decades, through the effects of sudden climate shocks on inflation. Then I'll share some conclusions and potential policy implications before posing two discussion questions to the group. First, on the topic of the Marxist roots and the kind of theoretical framework around climate change and inflation. So, these two forces intersect in large part through the framework of supply and demand. Essentially, symptoms of climate change lead to shifts in supply and demand, thus creating inflationary forces. This is clearly seen, as I will broach further in this video, it's seen through the accentuated impact of various climate events on food inflation, which is one of the economic sectors most dependent on environmental stability to flourish. So, inflation as a concept is highly related to two key aspects of a market economy: supply and demand. So, Marx's work on the impact of capitalism on environmental stability is crucial to outline kind of as a predecessor to all this talk of inflation. Um, Marx talks about this concept of metabolic rift, basically the decreased arability of soil due to capital engendered over agriculture, in which the soil loses key minerals required for its own fertility, one of these minerals being nitrogen. We can take Marx's kind of concept of we can take Marx's concept of metabolic rift and extend its logic to inflation in contemporary free market economic contexts. So while Marx's metabolic rift uses that specific example of food production and agriculture and kind of just talks about environmental stability, a similar pertinent example can be used to demonstrate how metabolic rift actually applies to the contemporary economic context. So, a potential hypothetical could be, for instance, a temporary increase in banana prices due to flooding, that flooding being influenced by sea level rise. And this flooding destroys banana crops and reduces soil arability over a certain period of time. This ends up leading to a sharp decline in the supply of bananas while the demand stays stable. So the laws of basic macroeconomics would state that this will lead to an increase in the price of the remaining bananas, therein inflation. So this is how Marx's concept of metabolic rift connects to our modern conversation of climate change and inflation. So with that kind of basic theoretical framework out of the way, we can dive into some of the more contemporary literature. As I've mentioned, this is twofold. So we'll start by talking about global and regional temperature warming and the historical and future impacts on inflation that this has. So, in a study sampling 121 countries in the period of 1991 to 2020, the effects of temperature increases over time were measured, and future projections were made based on this. In the historical lens, temperature increases led to increased headline inflation, with food inflation specifically being twice as highly impacted as headline inflation. So this kind of ties into the argument in that it ascertains that food inflation is one of the largest contributors to environmentally caused inflation, and that food is the sector in which said inflation is very much caused by the supply side of things, not the demand. To give an example of some of the numbers we're talking about here, the projections from 2020 to 2035 suggested, at best, 1.49 percentage points per year inflationary forces caused by gradual temperature increases, and in the worst case, 1.79 percentage points per year. So this is in the food sector, and if you look at the headline inflation sector, it is pretty much exactly half of that. So, in the headline inflation, it's 0.76 to 0.91 percentage points per year. And then if we increase the projections all the way up to 2060, the worst case scenario shows annual increases of 4% at worst. So clearly, there is a consistent, measurable impact of gradual temperature increases on inflation. Though, again, that impact is consistent, it is relatively predictable. It affects more generally countries near the equator where temperatures are already higher. So that has some implications to discuss later on. But it's more interesting as well to delve into kind of more climate shocks and the shorter term impacts that those kinds of events can have on inflation. These climate shocks include temperature shocks, drought shocks, and storm shocks. So when we think temperature shocks, think things like flash freezes and heat waves, and then droughts and storms are rather explanatory. So when taken together, these are climate shocks. So a study measuring the impact of these climate shocks on inflation was carried out by the International Monetary Fund, sampling 173 countries over the period of 1970 to 2020. It's important to highlight this as it provides a contrast to the gradual effects of warming. While the effects of gradual temperature increases consistently increase inflation to varying extents, sudden climate shocks have more nuanced and often more dramatic effects, sometimes leading to deflation, inflation, and both within a 5 year span. The IMF study actually filtered its results by advanced economies and developing economies. So this allows us to draw some really interesting conclusions. The study found that the same type of shock, for sake of argument, storm shocks, can have drastically different inflationary impacts depending on whether they occur in a developing economy or an advanced economy. In terms of headline inflation, temperature shocks actually led to inverse impacts in developed and developing economies. So, for instance, in advanced economies, temperature shocks led to a steady increase in inflation, while they led to a consistent decrease in inflation or deflation in developing economies. Food inflation, on the other hand, experiences a significant increase as a result of drought shocks in both advanced and developing economies. Storm shocks lead to an inverse pattern, with advanced economies experiencing a precipitous deflation in the first 2 or 3 years after the storm shock, while developing economies experience a significant inflation in that same time frame, with both returning close to baseline by the fourth year post impact. So I'll show those charts up there on the screen right now, and you'll see what I mean. It's the same shape, but inverted. So, what conclusions can we draw from these two studies, and what are some of the policy implications therein? The most obvious one is the vulnerability of the food sector to climate related inflationary impacts. While climate impacts influence headline inflation and inflation in other sectors, the common thread between both studies is the particular vulnerability of the food sector. This has important implications for humanity's preparation for worsening climate impacts over the coming decades. Since food is a basic human need, the outsized impact of climate events on its price could have significant negative effects, both in advanced and developing economies. While food inflation can be similarly impacted in advanced and developing economies by all these different climate forces, whether they be gradual long term temperature increases or climate shocks, we have to think about how in the global south, countries near the equator, the especially the gradual temperature increases are more severe. So the increases in temperature are higher, which will lead to these countries having worsened inflationary impacts. Because, yes, if you look in a vacuum, you know, increases in climate events will lead to increased food inflation across the board. But you have to look at it on a per climate event basis, and places that have more climate events will necessarily experience more inflationary impacts. This has really important policy implications because the countries that are going to be often uh, most affected by these inflationary impacts, by these climate shocks and climate events, are also some of those who are least prepared economically to deal with those impacts. This brings us to the implications that this might have. So, what implications does this hold for global environmental policy? The implications are significant. So, regardless of the level of support advanced economies provide for those most affected by climate change, the developed economies in the global north will need to address the results. So, whether developed economies choose to be more protectionist and not to provide humanitarian and economic support, or whether they choose to provide support, there will still be negative results for them. For instance, if these developed economies choose not to support, there will be an intensified climate migrant crisis, and political volatility will become more and more commonplace, threatening the safety of the international order. So, doing nothing is really not an option. It's kind of beyond the scope of this video, this presentation, to determine exactly what should be done, but doing nothing is definitely not an option. So some kind of coordinated action is required to counter this. Otherwise, there will be negative effects. There will be negative effects in either case, but it's in everybody's best interest to mitigate these as best we can.